Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be talking about time, speed and distance, right? So this is the next part for time, speed and distance. I think it's the fourth part, but this video is specially for the CAT exam, and this video talks about a certain type of question, a certain type of question in time, speed and distance, right? So what exactly is that question? The question is that, let's say for example you have two bodies here. Let's say you have body A and you have body B, right? And there is some distance between them. So body A is coming towards body B and body B is coming towards body A. They actually meet at some point, right? So let's say this is the point at which they meet, and then body A covers the remaining distance in, let's say, t1 time, and body B covers the remaining distance in t2 time. The question would be to find the ratio of their speeds, right? So that would be a typical question. Well, I personally would solve this question by setting up the algebra, by setting up the question. But there's actually a much quicker way of solving this problem, right? So there's actually a much quicker way, like in few seconds. It requires you to understand a specific formula, a specific expression, right? So if you want to do that, it's completely up to you. If you like setting up the problem, you can always set up the problem the way I'm actually going to set up the proof here, right? So that let's go ahead and get started with that. So let's suppose if I use the same setup, right? So I say, let's suppose there's body A and then there's body B, and there's some distance between them. They meet at a point. Let's say this is the point that they meet, right? And when they meet at a particular point, body A, it takes t1 hours for body A to complete this distance, and it takes t2 hours for body B to complete this distance. And let's say they meet after t hours, right? So they meet after t hours. So we have three different times. So first they meet after t hours, and after t hours it takes body A to complete t1 hours, and it takes body B to complete t2 hours for the remaining distance. So distance is equal to speed into time. That is something that we know, right? Let's say that the whole distance is actually equal to d, right? Now body A is also covering distance A. Body B is also covering distance d, right? So they both are covering the same distance, right? How much time does it take for body A to cover the whole distance? It takes t hours, and then it takes t1 hours, isn't it? That's the time it takes. It takes it t hours, and then it takes it t1 hours. For body B, it takes it t hours, and then it takes t2 hours. So this is the time taken for body A to complete the distance d, and this is the time taken for body B to complete distance d, because body A first, it takes t hours to complete this distance, and then t1 hours to complete this distance. So the whole distance is d. For body B, it takes it t hours to complete this distance and t2 hours to complete this distance. Let's say that the speed of body A is A and speed of body B is B. So distance is equal to speed into time, and distance is equal to speed into time. So we have these two expressions, right? Another thing is that the distance over here is also covered in another way. So the total distance is covered it's actually covered in some other way as well. That is, it takes t hours for body A and body B to cover the whole distance d, because after t hours A has covered this much distance and B has covered this much distance, so they have actually covered the whole distance. So their relative speed is A plus B because they're coming towards each other, and it takes them t hours to cover this distance. So this is for them together, that is A plus B. So distance is equal to speed into time. When they're coming towards each other, their relative speed is A plus B, and their time is t, and this is distance d. Now I have these three equations. Now what do I want? I want the ratio of their speeds. Ratio of speeds of A by B. That is what I'm interested in. This is what I want to find, right? So how will I find that? So I have three equations, so I can set it up. I can say that all three are equal to each other. So that means D is equal to AT plus AT1. That is from equation 1. D is equal to BT plus BT2, that is from equation 2, and D is equal to AT plus BT. So this is equation 1, equation 2, and equation 3. So now if I equate equation 1 with equation 3, I get AT plus AT1 to be equal to AT plus BT. You can see this and this gets cancelled, so I have AT1 is equal to BT. So that's one expression. Another expression that I have, if I equate equation 1 to equation 2, that is BT plus BT2, that is equal to AT plus BT again. So I can eliminate BT and BT, so I have BT2 to be equal to AT. Now what I'm going to do is I'm going to divide these equations. So if I divide these equations, the first equation is AT1 is equal to BT, this one. The second equation is BT2 to be equal to AT. Right, so I'm dividing this equation by this equation. As you can see, T and T gets cancelled. This T1 by 2, T2 remains here. This A by B, it goes there and it becomes B by A. Right? So that means B square over A square is equal to T1 over T2. That means B over A is square root T1 over T2. So this, after doing all this, this is what I come to. If after meeting it takes T1 hours and T2 hours for them to cover the remaining distance, the ratio of their speeds is going to be the inverse of the square root of their time taken. Right, so you can see that it took T1 hours for A and it took T2 hours for B. So their ratio of their speeds is the square root of the inverse of their time taken. Right, so this is what I did. I'll just explain one thing again. So you have this is their rendezvous point. This is where they meet, and after this it takes T1 hours for B and T2 hours for A. Sorry, T1 hours for A and T2 hours for B to complete the distance. They meet after T hours. So I have these three equations set up, very easy equations. Distance is equal to speed into time, nothing more than that. I solve these equations, I get this. Right, so the ratio of their speeds is square root of T2 over T1. Right, so that's A by B and this is B by A. Now if you don't want to do this way, it's completely fine, but you can do it this way as well. You can actually set up the equations and solve the questions, which is usually what I do. But now, once you know it, it's very hard to get it off your head, right? So once you know it, you rather would use it, right? So if I show you a question here, so you have these two trains, one from Howrah to Patna and the other from Patna to Howrah, start simultaneously. After they meet, the train reached their destination 9 hours and 16 hours respectively. What is the ratio of their speeds? So if they reach 9 hours and 16 hours respectively, the ratio of their speeds is actually going to be equal to 3 by 4. So our answer is option B here, which is 4 by 3. Right? So you can just solve it right away. Rather than doing it and solving equations, you know that if you have 2 points and two bodies are coming towards each other, they meet at a point, it takes it T1 hours, it takes it T2 hours. So the ratio of their speeds is going to be square root of T2 over T1. Right? So a good thing to remember that will actually make you faster. It builds up another theory on the top of what you already know. Right? So this would be about the video, guys. Thank you very much for watching this video, right? I really appreciate it. Make sure that you explore our website, you like our Facebook page, and if you have any feedback, give us at our email address. Just make sure that you visit our website because we have a lot of exciting stuff. So you can either visit this URL or you can even visit perfectscores.org. Right, so you can either visit either of the URL. They both direct to the same website, right? So this would be about this video, guys. Thank you very much for watching this. I'll see you in the next one.